Hi everybody, it's Saltash Math Tutor, and today we're going to be looking at y, the derivative of sine x equals cos x, and y, the derivative of cos x equals minus sine x, because I think you're going to find it's relatively easy. Just for some things we need to bear in mind though, is that the tangent of any line is the, however you do it, the rise over the run or up the stairs and down the corridor, however you derive it, but a line like this would be positive because you've got a positive value here and a positive value here. And if the line looked like this, then there would be a negative movement there over a positive movement there, which would be a negative. So in other words, this is a positive slope and that is a negative slope. Also importantly, if we've got a curve and we have that curve, and I'm just drawing two curves on here carefully, then if we take that line just as it touches the curve, then that is the tangent of the curve, and again we can say whether that tangent is positive or negative. On to the next slide. Okay, and you're going to go, whoa, look at this. Let's just introduce you to what we've got here. We've got the cos curve here, and you'll start to see some familiar values like cos of 0 equals 1. Cos of 90, I've also put radians in here just because, let's be geeky about it, is pi over 2 radians. You can see this is the cos curve, and all I'm going to do is, bearing in mind how we took those tangents, take cosine tangents, find out what the value of the tangent is at a point on the curve, and then we're going to plot it down here, and hopefully this will become sort of easy to see once I get going on it. So the first thing I'm going to do at the top of the curve, as it were, is take, whoa, not do that at all, take the tangent there of the cosine curve, and you can see, although a little bit badly drawn, that the tangent at that point is 0. So just chopping pens, let's take this, then that means that I can plot the point here. And then I'm going to plot the tangent at, I'll just pick an arbitrary point here. Oh, that's really badly drawn, isn't it? But that's a bit better, and we know that that is a negative curve, so it's going to be, and I'm almost plotting it on the same point with reference to the angle scale here and here, and so at that point it's negative, so it's sort of going to be about here, I guess. And then I'll just change colour here. We get, if you like, the maximum downslope, which is there, and the value of that maximum downslope is, because it's negative, is 1. Okay, so we're going to get a point here. Then, well, at this point here is a point of inflection, and what that means is that as the, if you like, the tangent has been getting steeper and steeper, at this point of inflection at 90 it gets less and less, but it's still a negative value. So the, let's put some tangents in. You can probably almost see they're getting less and less, but they're still negative, so they get less and less until we reach this point here when the tangent is 0, and we get a point there. So if I was just to pick some more points, so when it's 3 pi over 2 radians or 270 degrees, it's 1 and it's positive, so 270 degrees and 1 is here. At 360 on the cosine graph, it's 0, so I'm going to plot 0 here. that's a positive value, but getting less of a positive value, so that goes on here. Here's a negative value, but sorry, a positive value. I'm getting confused here. Old age, everybody. It's a positive value, but not quite at the 1 level, which is here. So it goes here, and you can generally plot the tangents of the cosines onto this graph underneath. Well, here comes the clever bit. I say clever, everybody. And let's just pick a colour. Let's pick blue. And well, basically, you may see, and I'm just going to join the dots here. Look familiar? Well, it doesn't look really familiar, but here's one thing I do know, is that if I had the sine curve, well, that starts here. It maximises at the value of 1 at 90, comes back down here at 270 degrees, or 3 pi radians over 2. There is a minimum. At 2 pi, again, it's a value of 0. And if I join it up, that is the sine curve of, I'm going to call it sine theta. Well, what we're saying then is, whatever value of sine is here, if I minus it, i.e. the value of sine at 90 is 1, so minus sine theta is minus 1. In other words, what I've done is, by taking the tangents from here, plotting them onto a graph here, I can see that cosine graph, when differentiated, i.e. differentiation finding the gradient of the curve, and plot it down onto another graph in relation to the x-axis, which is the degrees or radians, then I get the minus sine theta curve. And that is why, if I differentiate cos theta, I get minus sine theta. And in a very similar way, if we take sine theta and we find the tangents of that, which I'm just highlighting here, and look at the values and the sine of those, these get plotted to these points here, which I'm just highlighting, and then if we consider, when I've plotted the values of the tangents of the sine theta, what it looks like, well, it's cos theta. And that is why, if I differentiate sine theta, it equals cos theta. I hope that's been of some help and made it a bit more intuitive as to why these two differentials, these two trig functions as they are. This has been Saltash Maths Tutor, and I hope you understand that a little easier than my last sentence in the past 10 seconds. If you've got any comments or anything you want me to do additionally, then please post it. Thank you.